Hello, welcome to this demonstration of the Indent Grapher. This software is used to analyze the nano indentation data. This software does a lot of the hard work of interpreting the unloading curves to measure the elastic modulus and also the hardness. To start, open File and Import. Then select the file. In this case it's a steel ferritic. This lets you see the data file and also see the results of the conversion of the import. So in this case the H's represent the header. The header should stop where the data starts and only be highlighting where there's text. For example, if this was number 3, you could see that the headers stop at number of points 5,000, but all the data going into the software for graphing is now questionable. So you could use the guess button and it will automatically find the first set of data. If it isn't finding it, you are able to change these edit boxes to the value that corresponds with your data. The software also finds the depth scale. For example, if it finds that it's in nanometers, then the data is imported in nanometers. If the value isn't given, or if it's in a different scale, then it's converted to nanometers. Radio buttons are used to select the conversion. Okay, let's load the data. The first thing you'd want to do once the data is loaded, for example, is to measure the hardness. To do that, click anywhere near the indentation hold time. What that does is open up a dialog box of the parameters used to measure the hardness. You can select hardness Martins, hardness Vickers, or Rockwell scale A. If the indenter needs correction, you can also add those values here. This also compensates for frame compliance or Snedon's material epsilon. Click the OK and it changes the mouse cursor into the final results. These results can be dragged and dropped to the location on your graph where you'd like them displayed. The next thing we're going to do is measure the elastic modulus. To do that, click on the unloading curve. Then it shows the parameters to measure the elastic modulus and Poisson's ratio. In this case, 24.56 for the standard indenter without any corrections. We're going to solve for elastic modulus of the sample. Force range is going to be, let's say, 50 to 100% of the unloading curve, which is from this point to about this point. Then press the calculate. Voila, there's the result.